Hello, everyone, and welcome back to the stream. This is gonna be a short one this evening for a very simple reason, which is that I am sick. As you might be able to tell from, my appearance and the fact that my voice is probably not as loud as it usually is. So, as a result, I'm gonna keep it short this evening, and I got out of bed for this, and I'm gonna going back to bed right after. Right after, but there's a simple thing I want to tackle this evening, and that is addressing the issue from last time. Because last time we finished the stream on a slightly sour note. After spending close to 4 hours working on the parser, we ended up with something that did not pass a series of top level statements correctly because we encountered some ambiguities in the grammar. We encountered some shift reuse conflicts. So, this evening, before making any more deep progress on the AST and everything, I think uh, a good short task before I jump back into bed would be to tackle those remaining ambiguities in the language. I've had a look ahead of the stream to see what was remaining, and I haven't actually changed the code yet, but I don't think they're going to be too hard to fix. Interestingly, I've had a look at the Rust parser for the Rust language itself because some of those ambiguities stem from the way the Rust grammar itself is described in the Rust documentation. So I was curious to see, well, how do they handle that? Do they parse the grammar differently from what they describe? And the answer is interesting. They don't use a parser generator like Yak or Bison or a Happy that creates an LALR parser with only a one token look ahead. They use a recursive descent parser, which is the same thing that megaparsec is. That's very interesting because those are usually considered less suited for the task, mostly because they are not their performance concerns in terms of backtracking, and also they don't handle left recursion at all. Even I was going to say not handle it very well, but usually they just don't handle it at all. So it is not the tool I was expecting to see used to parse a programming language, which was very interesting. And the trick is, since they're using a manually written recursive descent parser, which is otherwise great, I love megaparsec and all the parsec variations. They use more than one token of look ahead. They look sometimes two token ahead to be able to distinguish between ambiguous scenarios, which we cannot do. So our task this evening is going to be to inspect the output of Happy to look at everything it says about the ambiguities in the grammar as described and fix them. Rewrite the grammar to express the same thing, but in a way that doesn't result in a conflict. So, let's get started. Let me just do that. There we go. If we look, I regenerated the debug file from Happy. If we look at this, we have a bunch of shift reduce conflicts. And those are actually, I should probably start by explaining what those are. And let's start with a concrete example. So state 32, which Happy has generated from for us from our grammar. Let me scroll so it's on screen for you. There we go. We encounter this if after passing a use path, we found one identifier and we are in the many use path item rule, which is trying to pass use path items, several of them, which is many use path item. It is this thing here. We've passed the identifier and we are currently passing the many use path items. Or we were already passing many use path items and we're recursively passing more of them. And here are the three possible things we can handle as, and that means we are at the end of the import statement, and we are now using like the as foo something to qualify the import, the use statement, or semicolon, and that's the end of the use declaration, or colon. And here is where there's a conflict. We can either shift or reduce, hence the shift reduce conflict, which means either we consume the next token of the input and we continue passing the current rule we're in, or it's like, oh no, actually there's another rule that ends here and we go back, the reuse. In this case, shift and enter state 42. If we look at state 42, that is, we're still using, after a use path item, we are still matching more parts of the import path. So we're expecting after this double colon an identifier. If we go back, the other is we reduce using rule 13. And rule 13 is that we are basically at the end of the use path. It corresponds to this like use tree here. So basically, when we match this double colon, is it the one here at the end of a use path, or is it the one here in the middle of the path? And happy is like, well, could be either. So between it's this one and we have to consume more tokens, or it's this one and we're done, we can just go back, we have the rule to apply now. It always chooses the shift, and which is, in this case, trying to say, okay, we're in the middle, we're continue to process things, which means it never passes this thing as being the end of the use path one. And as a result, if it finds a star or an open brace, it fails. It's a pass error. So that's why we're failing to pass use declarations at the moment. So we're going to have to rewrite this in a way that resolves the ambiguity and removes this double use of the colon operator. And I think the solution here is going to be right recursion, which is not the best use case, but is fine. Specifically, what I was thinking of doing, and we can try that directly, we might have to rewrite things around the import. So for now, I'm not going to test the Haskell bit. I'm only going to test the happy bit. This is going to be, it's always going to be an identifier followed by either, if we write this as right recursion, it is always, so it's either an identifier followed by nothing else, and that's the end of our use tree, we're done. Or, oh god, the formatting is bad. Or, what do we have? If it's not an identifier, no, it's always an identifier. The question of what comes after. And either after that we find this, and that's the end. Or an identifier and this, basically. Or, and that's where we're going to do our right recursion, an identifier, the double colon, and we find the rest of the use tree. And that, I think, should work because it's never ambiguous. It's one of those four. So either there is nothing, we don't match the double colon after the identifier, it's this case, or otherwise we can see which one we match. I think happy will be able to disambiguate this using the right recursion. Now, I just need to adjust a few things. I need to fix the Haskell code that is being returned. That's not the most important part, and if it doesn't, like, I'm not gonna try to compile it, at least not at first. That's not what matters. Because we have one more case to deal with. So in this case, this is just a qualified S2, that's correct. That's exhaustive instead of qualified S2. Wait, no, that's not correct. What did I miss? Yes, it's the optional use alias. There we go. That's what I've missed here. And here, this is the version where we have the specific list. That should be it. There we go. And now we need to handle, I've deleted it because I can't type. I should really keep this stream short. I am too tired for this. This is the version with the recursion, where we get this and we get a recursive use tree. And in this version, here $3 is the result of the recursion, so it's something that contains an import statement. Which means if we look at our AST, it's an import that contains a path, which is the list of the identifiers we have encountered, and the modalities of the import. So either fully qualified, exhaustive list, or a specific list of symbols to import. So in this case, what we're going to do is just basically prefix the existing import with this new path we have found here. And I might just use a separate function for this to avoid littering complicated, deconstructing, reconstructing a struct at this level. It's going to be a prefix import of $1 and $3. And let's define here prefix import is going to be given some identifier and an import, return the new import, and that's going to be given some what we do is we replace one thing in import. Actually, I could use lenses. I meant to in the first place. What's the make lenses? Is that the correct? Which means I'm gonna need to enable template Haskell here. That's fine. Import control.lens. That should be enough, which means here I can rewrite this as being a function from import to import, which I can do with lenses because it's going to be, oops, I didn't mean to do that. I meant to do this search here. There we go. That's a type of import. With the lenses, I can just say that this is a modify of import path. And the modification I apply is putting prefix at the beginning. I think that's correct. If I stack GHCI that. Okay, it's not compiling, that's fine. Because I just want to test import control.lens. I want to look at the type of modify. Yeah, it takes a function from... Oh no, modify is the multi-state version. Is it over that I want? It is over that I want. Over import path, you put the prefix. There we go. Okay, and this is... Why is it compiling actually? Not in scope. Oh, that's because I have this. Okay. Lenses are fantastic, but the use of template Haskell to generate them has one major downside, which is that while in a Haskell module, the order of declarations doesn't matter, which is why I can do stuff like a module is something that contains declaration, and at a later point in the file say actually a declaration is. because the order of the declarations in the file doesn't matter. As soon as template Haskell is introduced, that is no longer the case, and the order of declarations matters. And this thing to make lenses actually is using template Haskell, and therefore putting it in the middle of the file was breaking half the stuff. If I reload the code now, that should be fine. There we go. Which also means that this little function we made works, which is always good. Now, with this, we have rewritten this as write recursion, which should provide a very clear list of cases for this operator. And now, hopefully, Happy should be pleased about it. If we regenerate this, aha, there is one fewer state, and now this is no longer ambiguous, so we should probably be able to parse. If we go back to our stack GHCI, we should probably be able to parse the thing we were struggling to parse last time. Come on. Any second now. There we go. If we go back and we try to parse the thing that was breaking last time, like this, nope, it still doesn't work. Huh. Wait, last time that was because we hadn't recompiled properly. And it was using the wrong version of the files. Aha, and indeed here, something is wrong. Something about our import is incorrect. Okay, so let's fix the Haskell stuff so I can figure out what's wrong. Aha, here I want the location, but identifier is a tuple location and identifier. So here, this is not $1, this is get raw identifier of $1. Likewise here and here. And in fact, here we need to do the same thing. Here. Aha. And that's because I did not import control.lenses in this module. Okay, now it's slow, which is a good sign. Means it's actually compiling. I'm not sure why the GHCI version is getting the wrong files until I've actually forced a recompile otherwise. Maybe some kind of interaction between stack and GH and Cabal? That'd be weird. I don't know. Anyway, now... Aha. Yes, parser error, expecting a semicolon. There we go. Now this works. And now if we have other names in between... There we go. And this is an exhaustive declaration because we're using the star. And if I use instead this... Okay, that seems to be working. And otherwise, this case. Okay. So we have fixed the error that stopped us last time. We fixed one shift reduce conflict. And there is, how many of them is there to go? 78. The good news is a lot of them are actually just a copy of the same problem. So we're going to go through them, and every time we fix one of them, several of them are probably going to disappear. So let's have a look. State 52 contains one shift reduce conflict. What is state 52? Aha. Yes, that's something I've noticed. My reference document does not mention the proper syntax for generic arguments to a function call. And I meant to copy the one from Rust, and I did not do it properly when I wrote the grammar. So the grammar is slightly wrong. And as a result, it is ambiguous. So we should probably fix this. Because at the moment, there isn't the double colon thing to introduce the type. So it's directly like in C++, the open angle bracket. And as a result, here what Happy is saying is it could be either like shift and enter state 119, which is we are continuing passing a generic argument, or it could be reduced using rule 149, which is on here, but this is actually the less than operator, and we are done passing the previous expression. Should we continue because this is the middle of an expression, or are we just done with something and should we reduce? It defaults to shifting, which means every time we do foo underscore angle brackets, it would parse this as a generic argument and not as a comparison. That's my fault. That's on me for not writing the grammar properly. So let's go fix that. This is something we have not. Okay, this is still in the expressions side of things where we have not done the code yet. So it is still a bunch of undefined. So we won't have to fix the Haskell code here, which is going to make it easier at least. Where is it? There we go. So here the generic argument is going to need to be prefixed with the double colon. But we are going to run, if we do that, into the same problem as before, where we will not be able to distinguish between is that double colon and then identifier because we're in the middle of the path, or double colon followed by the possibly generic, followed by the generic arguments. So we need to be able to distinguish between them. So we're going to rewrite this as a right recursion there again. So this is the end of the recursion. We have an identifier and optionally some generic arguments. Actually, can I rewrite this as we have an identifier, we have an identifier followed by this and then by generic arguments. Or we have the recursive call, which is we have an identifier followed by this, followed by a path expression. That should work, right? It's right recursion there again, but that way, I think that covers it. A known identifier path expression item. So I'm no longer using it. Aha. A type expression was also expressed using a path expression item. Yeah, I guess it's basically the same thing as a path expression. What's the difference? Is there any difference there? There is probably a difference in how we want to parse this. So maybe I want to write it as a separate rule that behaves the exact same just because I want to handle the result differently. Maybe I will come to decide that, like, no, actually this is fine and there's no need to do that. But for now, since we have not done this part of the AST yet, I am going to err on the side of caution and do that, basically. So basically, it's the same thing. I guess in all of those, I should support the having a double colon at the beginning as well, which I don't. We can do that later. 76, we have removed 2 more things. Okay. Now, state 85. That's why I think this is a good thing for this stream where, like, my brain is not fully working, because I just follow what Happy tells me and we fix the bugs. And we get to talk about parsers then it's in the process. Not too hard. So, Shift and Enter state 130, reduce using rule 53. Oh, so we've just parsed a path expression, which is the thing we were looking at, which is like basically the name of something, name of a variable, name of a function, name of a constant, a name basically that contains some path and possibly some generic arguments, but not necessarily. We've parsed that, and we encounter an open brace. And what here Happy is saying is, I don't know if this is, I'm assuming state 130 is the record syntax. I don't know what else it could be. Or I reduce under rule 53 because that open brace is not part of an expression, and therefore we are at the end of a path expression. And I think, so here I think the default of shift is correct because I don't see any other expression in our made-up language in which a open brace would follow an identifier like a path expression like this. There's only the struct like creating syntax. Let's check what state 130 is. Yes, it's a struct expression. So it's basically like this is this brace. So it's like, is that, we've just finished parsing a path expression, we encounter a brace. Is that it? Or is it something else that we should parse differently? And the answer is no, yeah, that's the only thing that exists with a brace after a path expression. Therefore, here the shift is correct. Which means either I find a way to express this with precedence that, like, it is always correct to shift here, or I just accept that there's a shift reduce conflict we don't care about. For this evening, I'm gonna choose the latter. I don't care about this one. Actually, I want to see the next one. State 126. Oh, we have 2 things. We have as. If we reduce, it means we consider that. Here, deciding whether shift or not depends. I think we should shift in the sense. Wait, no, we should reduce. We should reduce because we want to treat this as a negation expression and the as is not part of it. It's not minus 3 as, it's not minus 3 as int. It's, wait, or is it? The difference is between minus 3 as int or minus 3 as int. And let's see what the reference has to say. Aha. As has a lower precedence than unary operators. So minus 3 as int is minus 3 as int. Okay. So here, what we can do for this one is replicate. I'm gonna put the documentation here. When we do at the top of the file, we list the different things. Here, the one that like is the has the highest precedence. Therefore, at the bottom of the list, where here I have them at the top of the list, is unary operators because I don't have a precedence thing for this. I could, I guess, make the open brace of I could make the open brace of a struct in the list here. That would probably fix the shift reduce conflict, I think. Probably. But here, so we have unary operators, and between that and the exponentiation operator, we have the as operator grouped left to right, so left associative. So that's this, and that should fix our issue. What was the other one? There was another one in the state we were looking at. Ah, the dot. What's the problem with dot? Reduce your using rule 89. Oh, so it is again. If we have minus a dot b, is it minus a dot b, or is it minus a dot b, or is it minus a dot b? And I think it's the former. And field expressions tight are like higher precedence than unary operators. So that means here we need an additional one left for dot. And we're done to 26 conflicts. That's 50 of them gone in one go. So that's a lot of progress. Oh, we have unused rules. Let's have a look. That's probably a consequence. That's probably a consequence of simplifying the grammar. So 14 and 15 are unused. Use path and use path item. Yeah, of course. We've replaced those two earlier. They're no longer needed. I can remove them. And 134, 135. Many use path item, the generated one for our many combinator. So by just removing them, okay, we should have something that's correct. Let's go have a look at state 85. Oh, open brace. Oh, wait, that's one we had already seen. Okay. So here, what's happening? Open bracket. If we reduce, it's using rule 87. Okay. So negation expression again. So this is a precedence problem. So it should be easy to fix. And otherwise, we enter state 157. That's an array index expression. So we have an expression and we have like we're indexing something. And that is covered in the reference as well, I think. Array expressions are here above even function call and field expressions. So it should be just a matter of adding a no wait, field expressions at the same level as array indexing expressions. So I should put it on the same line. There we go. Now, there we go. We're done. That's all of it. We are done to one shift reduce conflict, which is the one for struct. which actually we could probably fix. Since braces are used for more than one thing, I'm going to be explicit here. Struct expressions are so here, and they're non-associative. I'm going to name it struct. Uh, do I just... How does that work? I'm not sure this is going to work. If it doesn't, it's fine. I don't remember the syntax. I'm looking for it in other things. Ah, there we go. I don't know if this applies, oops, to just one thing. Parse error. Okay, so it should be applied to this whole thing, I guess. Will that be enough to fix the shift reduce conflict? It is not. Therefore, I am not going to use it here. I guess I could try that. No, still one. Okay. Since this doesn't seem to be doing the trick, I want to add something I'm not sure about. And since anyway this shift reduce conflict is unlikely to be any problem in practice, I'm okay with it. Okay. That should be a lot better. So now let's try... we still can't pass expressions, though we're still fairly limited by what we can do. Yeah, I was going to try more things, but we have already tried passing import statements and expressions. We're not yet at the point where we can do that. So I guess on Tuesday we'll get back. Now we have a grammar that like is no longer ambiguous. We'll get back to finishing parsing everything. We're only missing expressions, which shouldn't be that much more work. Famous last words. And then we can start working on either the compiler phase or like the analyzer phase, or we can start doing some of the bytecode stuff for a break. I'll decide which one I want to do by Tuesday. For now, again, this is going to be a short stream because I just need to get back to bed. So I am going to stop here and commit this. Actually, this time I'm going to commit it now before I forget. What do we have? We have a change to the AST. Yeah, I'm gonna bundle this with the changes to here, because the only things we have are making the grammar left recursive to fix the import problems. Okay. Just scratch that. There we go. Ah. Resolve grammar ambiguities, I guess. good enough. And with that, that's done. And yeah, given my current state, I think that's all I'm gonna manage to do today. So I'll stop here. I'll be back on Tuesday, health willing, for the regular weekly stream. And hopefully I managed to make the Thursday one also a weekly thing, because I would like to make progress on this project. I'm not used to not binge a project, having to pace myself, and only having this rule of only writing code on stream is difficult, but I think it's a good thing. So yeah, now we're in a better place grammar wise, and we can finish the AST next time. And yeah, that's gonna be all for today. Thank you for tuning in. Thank you for tuning in, and have a good weekend. I'll see you on Tuesday.